you're going to take a look at is imaginary numbers. The first 5 questions will have imaginary numbers. You'll have ones where it's just reducing radicals, something like that. Just reduce that. And so the first thing you want to recognize is you can always factor out the negative because that's I. And then you want to factor out the largest perfect square. So in this case, I can pull out a 16, which would be left over with 2. And so when I simplify this, we'll end up with 4 from the 16, radical 2, and then I. Some people are asking, can I put the I in front? That's fine, I'll accept that. But technically the I should be at the end because it's the imaginary term. So some people will put this little like end piece on their radical so you know the I is not underneath. But this will work, or you could give it to me as 4I radical 2. I'll accept either for tomorrow. Next piece you'll see is the fraction one. So you'll see something like 12 plus radical negative 8 all over 2, something like this. Okay. That has a common denominator since it's all over 2. The biggest error I've seen so far is when people split this, they do 12 divided by 2 and then forget that it also applies to the radical 8. So if you're going to split this fraction up to reduce that 12, which you can and should, make sure you split it so the 2 is to both parts still. Because the whole thing is divided by 2. So this will end up being 6 plus, and then the square root of negative 8. If we looked at reducing this just like we did the other one, that would be the square root of negative 1, square root of 4, and the square root of 2. So this will end up being 2I radical 2. And so the 2's we'll be able to reduce here. So 2I radical 2 all over 2. Those will cancel. Remember that standard form for imaginary numbers is A plus BI. So when I give my final solution, this will be 6 plus radical 2I. That's why typically we'll put the I at the very end, is because it's BI. The next piece you'll do is that imaginary number to some power, so like I to the 30th. Okay? The thing that you should memorize, and hopefully most of us do, is that I to the first equals the square root of negative 1. Then you can derive everything else from there. So if I square both sides, I squared equals negative 1. If I go I to the third, it's like I times I squared. So this would be negative square root of negative 1. That's the really weird one. And then I to the fourth is I squared times I squared, which is just positive 1. And so from this, every single time we get I to the fourth, it cycles back through this rotation. So I want to figure out how many I to the fourths will go into the 30th. So this is I to the fourth. It goes in 7 times perfectly, because that would be I to the 28th. How many are left over? 2, so times I squared. I to the fourth is just 1. That's what we determined. So 1 to the 7th is what? It's just 1. So this whole piece of I to the fourth to whatever is 1. That's why we pull it out, because it's just 1. So what we're left with is just I squared. So I to the 30th is equivalent to I squared. So you can either give it as I squared, or you can just say that I to the 30th is negative 1. Okay? And if you have a calculator and put it into the A plus BI mode, you can actually type that in the calculator and it'll give it to you. But you should understand this and how that pattern works and why it works. Okay? So we're just doing exponent tricks. The next 2 pieces you're going to have for the imaginary numbers is, the first one is just squaring something, so like a 5 plus 2i squared. Okay. Make sure you don't just square the 5 and the 2i. Remember, this is actually 5 plus 2i times 5 plus 2i. And then make sure you FOIL and get all your parts. So in this case, you'd end up with 25 plus 10i plus 10 more I plus 4I squared. I squared is -1. Okay, so to fully simplify this, make sure you substitute that back in. This is essentially -4 now if we plug in -1 for I. And so you end up with 21 plus 20I. That would be in standard form, fully reduced. The other part we'll see is the 15I over 3I minus 2 or something like that. Okay. So this is that one where I have an I in the denominator. We don't like that because it's a radical, so we got to multiply by its complex conjugate, which another word for that is take that and multiply by itself over itself, but flip the sign in the middle. So if we multiply this out, you would see you have 45I squared plus 30I on top. On the bottom, the whole reason why you multiply by the conjugate is because you get that difference of squares thing, so those middle terms disappear and the denominator will become a real number, so this would be 9I squared, and this is plus 6I minus 6I, which is the whole reason we did it. That'll disappear, and then minus 4. Okay? So in this case, our middle terms will disappear. Up top, this is just -45. This is that -1 for the I. So we get -45 plus 30I all over, this is -9. So -9 minus 4 more is -13. Okay. And then to put it into that standard form, last step would be 45 over 13 minus 30 over 13I. That would be your final standard form. So that's all the complex number stuff you'll see tomorrow. And then we'll go into solving for x with quadratic x. Yes, Regan?
Why isn't it -13?
Because -45 over -13 is a positive. And then positive 30 over -13 is a negative, so this is a minus. And so solving stuff again, I won't ask you which way to do it. I'll just say, hey, solve for x. So I'll give you one that is easily factorable, so something like x squared plus 8x plus 2, 5, and 3, so 15. So I could give you something like this. Okay, and I'll say, what is your solutions for x? So you'll say x plus 5 and x plus 3. And so our two solutions are going to be x equals -5 and -3. So we're good to go there. And then another one will be easy to do by completing a square. So maybe it's something like x squared plus 6x equals 2. And so that's going to be kind of an ugly one, but I can complete the square easily. I can't really factor it, but we can complete the square. And so when I complete the square, we'll have this x squared plus 6x plus something equals our 2 plus that same something. So I keep it balanced. And that something is going to be half of our b squared. So 3 squared, I have to add 9 to both sides. And the whole reason we're doing this is to create that completeness square. So I do these two steps at the same time because half of b gives me what the perfect square is. And then squaring that tells me what I needed to add in so I can go from there. Then we'll square root both sides. So I end up with x plus 3 equals the square root plus or minus square root of 11. And then x will equal -3 plus or minus the square root of 11. And this is an acceptable final answer. Okay, when you get an ugly radical. Okay, so you can leave it like that. And then the last one I'll give you is something that you're going to definitely have to plug in the quadratic formula. And I can give you the quadratic formula. You can do any of them in the quadratics, that's fine, but I can give you something like x plus 5 equals negative x squared or something like that. And so you would have to shift it all over so it's equal to 0. So this is x squared plus x plus 5, and I don't even know if there's a real solution to that, so sorry if that's a terrible example, but I will give you one that actually has real solutions that you can plug in. If you use your calculator and you're trying to use a program or something you have on there, okay, that's fine, but you have got to show me what you're doing and what your work is. Otherwise, it's an all or nothing. If you plug in the wrong value and all you give me is a number, you will get no credit for that, okay? If you show me what you plugged in and I see that, oh, you made an error moving one of the values around, then I can at least show, I can give you partial credit for that. Yes, Bregan? You good? All right. So there's the solving stuff. The last two problems you'll see tomorrow are similar to that one we just looked at, where it would be like an x squared minus x plus 6 is greater than or equal to 0. So it's similar to that one we just saw, where you want to factor and find. It's supposed to be a 6, sorry. 6. So we'll have an x plus 2 and an x minus 3. And so it'll say either by noting end behavior or checking the interval test method, okay, which again, all you're looking at is find your x-intercepts, which is x equals negative 2 and positive 3. And then go ahead and test, is this true? And so you'll have negative 2 and positive 3. So negative 2 or positive 3. And then based on end behavior, I know this is up, up. So I could either go and sketch this and say, okay, I'm above the graph and the tails. Or you could use the interval test method. I love to check the point 0 because I think it's the easiest one to plug in. If I plugged in 0 here, I end up with 6 is greater than or equal to. Oh, I screwed that up. That should be a negative 6. I'm sorry. My example's all messed up. Let's plug in a negative 6 there. That'll make this actually work. Okay, so then that would factor properly. We need negative 6 and a negative 1. Okay, there we go. So then if I plugged in that 0 for x, we get negative 6 greater than or equal to 0. And so we see that that is not true. And so since that's not true, it's not true in there, which we see graphically as well. And so our final solutions would be x as an element, and we're going to talk about the tails. So we'll go negative infinity to negative 2. And this is a square bracket. Anybody know why? Because there's the equal to, good, and square bracket with 3 to positive infinity. Okay. All right. So that's that interval test method type thing, and there'll be 2 questions like this. Okay. Both of them I think I made factorable. Yeah, both are factorable, so they should hopefully go quick. And we're just using this test stuff. All right, so that's tomorrow's test, all the computational stuff. Okay, then on Friday what you'll see is the profit type equation. There'll be a story problem where we're running a bakery. And so let's say I say we're going to sell cakes, and you can sell them for $8 each. And so you're going to say, well, my revenue equation then is $8 per cake. And so you'll have to build that equation. And then I'll say the space you're renting costs you $1,500 per month, and it costs you $3 per cake to make them. So we'll end up with a cost of $1,500 per month and $3 per cake. And then I'll say, hey, go ahead and find the profit equation for me off of this. So the thing you need to remember is that profit equals your revenue minus cost. So we'll end up with 8x minus all of your cost. And so when you put that all together, this is minus 1,500 and minus 3x. So this becomes a 5x minus 1,500 equals your profit. And then I'll ask you, where's your break-even point for the company? How many cakes do we need to sell? And so break-even is at $0 of profit. We'll add 1,500 over. We'll divide by $5 of profit per cake. And we'll see that our total cakes needed is 300 in order to break even in a month. Okay. Second question will be a projectile height one. And so I will give you the equation that h of t equals that negative 16. Again, that's gravity. That's why we always see negative 16t squared. That's gravity. Plus some initial velocity, which let's, just for the sake of easy numbers and trying to demonstrate some stuff, let me say that it's starting at 32 feet per second. And we start a height of 2 feet off the ground. Okay. So the situation tomorrow is we're going to have Lee hitting a baseball. We're going to see if he can actually hit it out of the baseball yard. I think it's going to be funny when I make it land just short of the home run line, how mad he'll be angry. It'll be funny. He's like, Freeberg, if I don't hit a home run, I'm going to be a little bit mad at you. So it'll be fun. Anyway, so in this situation, I'll ask the question, how long does it take to reach 30 feet in the air? So you'll plug in 30 feet for your height, and then you'll have to solve for when that happens. And so in order to solve for that, again, you want to get everything onto one side. So we'll subtract that 30 over. So 0 equals the negative 16t squared plus 32t minus 28. And then we can use the quadratic formula to go ahead and solve for that. And so you'll get a situation, you'll get two solutions. One will be where it first reaches that height, one where it falls back to that height. So the question will say, when does it first reach 30 feet? And so you'll give me that first solution. So your x is going to equal whatever this negative b over 2a is, plus or minus the square root of b squared minus 4ac, all over 2a. So you'll plug that part in. The next question will be, what's the maximum height the ball reaches? So again, you want to figure out what, or this is t technically, not x, since we're dealing with t. The time that it reaches its maximum height is just this first piece here, that negative b over 2a. So we can figure that out, and we'll know that our time is going to equal negative 32 over 2 times negative 16, which is negative 32. So after 1 second, I will reach my maximum height. Then if I want to go figure out what is my maximum height, I can go take that, plug it back in to the equation. And in this case, it would end up being at 18 feet. I'll never actually reach 30 feet. Okay, so I gave you a bad equation here for the demonstration. I apologize. Okay. The one on the test will be much higher. I just grabbed one that had easy numbers for this part of it. So we'll hit the ball much harder. We'll probably call it like 100 feet per second coming off the bat. That'll give us more realistic numbers. Yes.
Are we gonna have to like graph it on the test and show you it, or
no. You're just gonna find the solutions, the times, and the heights.
plug it into our calculator?
Mm-hmm. You know how to do it. Yep. Yeah. For which? Yeah, so you're just using the quadratic equation to solve for your time that reaches those heights, and then you'll find, and then find the maximum height and all that stuff. The maximum height equation is at that top piece. So if we think about how this works out, we'll end up with some piece that looks like this, right? And so that maximum height is at that axis of symmetry that everything is plus or minus off of. And so because that is the piece that is plus or minus off of, that gives us the axis of symmetry. That grabs that highest point possible. Otherwise, you can type in the calculator, graph it, and then solve for your maximum. Hi. Can you put your phone away? Because it's distracting you and everybody else, including your best friend hugging her backpack.
Oh, okay.
Got it. All right. So there'll be the baseball question with a projectile height, and then the last piece that you're going to see is going to be those equations where I'll ask for a new function rule, h of x, given that it's sum f over g of x. And so you'll need to plug those in. So demonstration on this, and then I'll ask you for the domain. and then I'll ask you to evaluate it at some like h of 3 or something like that. Okay, and so you have to find those values. So let's say that f of x is x squared plus 10x plus 16. And then g of x equals x plus 8. Okay. So in this situation, when you go to find your new h of x rule, you're going to end up with something like x squared plus 10x plus 16 over x plus 8. You can factor out that top so that it's x plus 8 times x plus 2 all over this x plus 8. What do we notice happens? That'll cancel with that. So our new function rule can be written fully simplified as just x plus 2. Okay. Your domain, when we look at domain, the top's domain is all real numbers. The bottom's domain was all real numbers. So the overlapping region in this case is all real numbers. But what's the one piece we got to look out for? We don't want to divide by 0. So x cannot equal negative 8 in this case. So my total domain would then be x is, you can write it as all real numbers where x is not equal to negative 8. That's okay. Or you can write it with the union stuff where it's negative infinity to negative 8, union with negative 8 to infinity. Last piece would then find h of 3. You can plug in h of 3 just to your new h of x function here. So h of 3 would be 5. Okay. If you feel like you totally screwed up on this part up here, or you don't know how to like simplify it, which is fine, you can plug in h of 3 in for all these x values here, and you'll get the same answer. It'll just take more math. Okay, so don't freak out that like if I screwed this part up, I won't be able to find this. Just go back to your original equations and just figure out what it is. Find f of 3 and g of 3 and just do that divided by that, and you'll end up with that number. Okay, the last question will be the same situation, but we're going to ask you to find f times g of x. So you won't have to worry about the dividing by 0 part, but you do want to go find your overlapping domain piece. All right, so that'll be your test. Good luck.